session is called Atoms and Isotopes. Now, the whole idea of the atom came about in about the year 1800. So this is where we start. We need a little history. Before that, there were quite a few elements known, but there was no real idea of was there a fundamental particle in the element. In the year 1800, John Dalton came up with something called the atom theory or the atomic theory. And it was developed by work from the previous 20, 30 years, Lavoisier, Proust, and others. But we had an atom possibility. Now, one of the big things, the premise of Dalton's theory, was that for any one element, all the atoms were identical. Now, for every element, of course, every element had different atoms, but within that element, every single atom was identical. That actually proved to be wrong because there was something called isotopes. Now, here's where we come into this. In 1900, we're starting a period of vast searches into something called the subatomic particles. We had the discovery of the electron, the idea of a proton and a neutron. And in about 1913, there was a major discovery by a British scientist by the name of Soddy. Soddy was working with uranium, and he discovered that there were two types of uranium. Both types acted the same chemically, but they had a different mass. One was heavier than the other. So we started a process that's tied into the same time period, 1913, 1915, 16, that range, with two British scientists. You've heard of probably J.J. Thomson, Nobel Prize winner for the discovery of the electron, and a colleague of his, Austin. Austin used the idea that Thomson got. They worked in something called a cathode ray tube, and Austin quantified the cathode ray tube using magnets, electrical fields, and he created something called a mass spectrometer. And they discovered many isotopes. But the difference was Soddy was working with radioactive or unstable isotopes, and the J.J. Thomson was introducing gases that were based on stable, or stable means they were not radioactive. And about the year 1930, 35, in that range, we had a great American scientist, Harold Urey. And Urey discovered a fundamental isotope of a variation in the weight of hydrogen. He discovers something that has hydrogen with a mass of 2. It was called deuterium. And in fact, deuterium in water, this is the formula for water, as you know, H2O. And of this hydrogen right here, this hydrogen happened to be a heavy hydrogen, H2, this became what's called as heavy water. And it was used in nuclear reactors as a moderator and a coolant, mainly as a moderator. Now, the idea of the isotope came about through these two scientists plus Urey, and it opened a field to chemistry, because initially chemistry was just made up of elements who were made up of single atoms, and all the atoms were the same. Well, what we ended up with something like, instead of, by 1900, there were about 83 elements known. But we could expand these elements, thanks to the idea of isotopes, to about 339 natural isotopes. Now that means they're in nature. And there are even many more that were unstable isotopes. Now, if you look at the periodic chart over here, you would see that of your elements, you're just listing for each element, and I'll start up here in the top. For hydrogen, for instance, it has an atomic number of 1, but it has atomic mass of 1.008. These units are called AMUs. Now, this 1.008 comes about because hydrogen is made up of 3 isotopes called hydrogen 1, hydrogen 2, and hydrogen 3. And we can list them this way also. Hydrogen 1 could be listed with a superscript and a subscript. 1 represents the mass number. That's the number of protons plus neutrons. And the subscript 1 is the atomic number. And that's the number of protons. The number of protons in the nucleus identifies the atom. All the mass together includes the neutrons. You'll notice the unusual thing about hydrogen 1 is that it has no neutrons. So you subtract these two and you get 0. But with hydrogen 2, you have a mass number 2, 1 proton and nucleus subtracted, and you get 1 neutron. For hydrogen 3, you get 2 neutrons. Hydrogen 1, the only element that has isotope names is hydrogen. Hydrogen 1 is called protium. Hydrogen 2 is called deuterium. Hydrogen 3 is radioactive, called tritium. Okay, so every element, it goes from a low of 3 isotopes for hydrogen to a high for xenon, has, I think, about 36 isotopes. Some are radioactive, that means they're unstable. That means they break down, give off particles from the nucleus, and some are natural. Every element, calcium, for instance. If you look up calcium on the periodic chart, you'll see that calcium has an atomic number of 20, but this number up here can vary. The most common isotope is 40, but you can have calcium 42, calcium 44, and it goes on, and there are about, I think, about 24 isotopes of calcium. So what do we have? We have the fact that in the 1900s on, we didn't have to deal anymore just with the elements as being all atoms of the same, but now we had the fact that there could be isotopes of each atom. The isotopes, and let's put this down, make sure we get it, because we don't have the word out here. The isotopes identified by their number of protons. That's the element, that's the name. But the number of neutrons, when they vary, creates a different mass for that element. For instance, hydrogen 1, hydrogen 2, hydrogen 3, calcium 40, calcium 42, calcium 42, 4. And some of these characteristics can be used to do additional work in nuclear chemistry, etc. We will stop right there.